was to reduce waste in both Phoenix and Belfast using IoT technology. We have incorporated Arduino into this product. The problem is that ASU and QUB both committed 35% of their emissions through lighting and electrical usage. Energy is not fully maximized and creates a significant and unnecessary carbon footprint.
We've aimed to simplify lighting controls in the home and workplace by tracking the flow of people and keeping count of populations. Our system can also help to better target emergency efforts by ensuring first responders know where or if they should look. Our presence detection light switch is a step above existing smart switches. It tracks occupancy and as a result can be used as a part of a security system. The switches can be networked together to upgrade any home or even just rooms. It is also capable of taking inputs from multiple detection technologies like RFID for identification or ultrasonic sensors for accurate tracking of position.
Our proposed solution provides many features to an end user. The board is pre-coded and implemented into a light switch, which means it is safe from tampering. It is also compact and cost-effective through the implementation into the light switch enclosure. The modularity of the solution means it can be adapted to any implementation and use case. We use throwaway prototyping to test our initial idea with the Arduinos and a breadboard. We then tested the viability of the proposed solution to the prototype by using the light-dependent resistors. The output of the system, in this case, is represented by a single LED. However, an end user could attach this to a whole range of systems.
The final prototype, we took the preliminary prototype and we miniaturized it onto a single small breadboard and attached it straight to an Arduino. We then put it in an enclosure along with the 7-segment LCD, and we were able to mount that on a laser cut display panel that shows there are 4 LEDs that indicate the room lights and also the doorway, which we can trip. That's shown in the next video.
Indicated by this dashed line. We can come out of standby mode right now. Then you can see the lights turn on and it indicates one person in the room because there has to be someone in the room to turn on the light switch. So then we can have people enter the room. So we have now two people in the room, and then we have 3 people in the room, and we can come down from that. We can go down to 2 people in the room, then we can go down to 1 person in the room, then we can go down to 0 people in the room. Then you see the lights in the room will turn off. Then we can go back up to 1 and the lights turn on. And we can go back to 0.
Okay, so the switch gives many benefits to society, such as reduced electricity use. So we stop wasting light by having lights on when people leave the room and there's no one in there. It's also that through that it's going to reduce carbon levels through less electricity. Also, that would provide cleaner air, and also it allow for automation with the buildings. So with the modularity of the actual system, it can be used by many different ways depending on the system that it will be integrated with. It can control, let's say, air conditioning, or it can control also the lighting and also other different tasks within a building.
For future developments, we would like to set up a network of these Arduinos in a building and integrating it with other systems such as room booking, but changing to an ultrasound over LDRs for increased reliability. Then after that has been completed, it would be possible to make an ASIC chip that would have all the functionality in a much smaller and cheaper package. This has been Team 5 from Arizona and Team Foxtrot from Belfast's presentation. Thank you for listening.